In this video, I'm going to show how we can interpret the gradient vectors of a surface, and also how these vectors are related to the level curves of a surface. It turns out that if we stand at a particular point in a surface, the gradient vector will always be the direction of steepest increase. The magnitude of the gradient vector is the square root of the directional derivative of f in that direction. In other words, the gradient tells you where the surface is steepest and just how steep it is. Here's the example from the second video. F of x comma y is equal to sine of x minus y. Recall that the gradient of f at x comma y was equal to the vector cos of x minus y comma negative cos x minus y. So at the point pi comma 0, the gradient vector is the vector negative 1 comma 1. We also computed the directional derivative in the direction 0 comma 1 and found that it was equal to positive 1. Here's a graph of the surface f. It's a bit like corrugated cardboard, where if you slice it in the x or y direction, you would see a sine wave in profile. This dot is the approximate location of the point pi comma 0 comma 0. The gradient vector is negative 1 comma 1, which points towards the back of this graph. If we were standing on this surface, this would be the most uphill direction that we could choose. The vector 0 comma 1 points in the positive y direction, which in this case is away from us. I hope you can see, though, that if we walked this way, we would still be going uphill, but not quite as much as if we chose the direction of the gradient. Here's another perspective, the contour plot. This plot is color-coded to show you the maxima and minima of the surface. The minimum heights are all negative 1 and are all in the middle of the red zones. The maximum heights are all positive 1 and are all in the middle of the yellowish zones. In between those extremes, one of those contour lines corresponds to height 0. Again, I'll draw the approximate location of pi comma 0 and also the gradient vector negative 1 comma 1. Notice something interesting. The gradient vector is perpendicular to the contour line that it's anchored to. This is always true. No matter what the surface, the point, or the contour that we choose, the gradient vector will always be perpendicular to that contour line. Finally, if we mark the vector 0 comma 1, we can see that the vector points towards lighter shaded or higher areas of the graph. We would still be going uphill if we went this way, but not quite as much as if we went up and to the left.